Hey everyone, my name is Abdeali and I'm the CTO at Corridor Platforms. And in this talk, we're going to be talking about how we at Corridor were able to introduce multi-tenancy into our application and just the different steps that we went through to do that. And one of the pivotal points was Werkzeug and the utility functions it provides, which we heavily use to be able to get to that state. So maybe let's just first talk about multi-tenancy a bit, right? Multi-tenancy, just the basic definition is you have a single instance which is serving multiple tenants. Now, what's an instance? What's a tenant? All of that's really debatable. So that's basically where most of the miscommunication of multi-tenancy comes up and the overloadedness of the word, because different people mean different things when they say multi-tenancy. Because an instance could be just a server, hardware, a particular application, software, whatever it is. And tenants could also be different clients that you're using or different users that you're using and so on and so forth, right? But a very simple example of multi-tenancy is when you're going to be buying a house or staying in a house, right? You either have like an independent house which you could stay in, or you could stay in an apartment complex where there are many tenants who are going to be occupying the same space. And there are different pros and cons, as you can imagine, for any kind of architectural decision that you'll be making. So even multi-tenancy has its own pros and cons, right? So one of the things that I would always recommend you to do before you go into the whole rabbit hole of multi-tenancy is make sure that it has the benefits that you're looking for. So do a detailed pro and con analysis, make sure that all the benefits that you're going to be getting is worth the negatives that are going to be coming along with it. Like, for example, the few things that people typically talk about when they're discussing multi-tenancy is ease of onboarding, because as soon as you have a new tenant that needs to start using your application, it's a very quick onboard and it's just another tenant in your hundreds of tenants which could already exist. Quicker maintenance, right? Because as soon as you deploy any maintenance scripts or even a patch for one of the tenants, it's immediately applied to all the other tenants also typically. And even scalability, because there are a lot of common resources that you could be leveraging for all your tenants, right? Again, the same example of an apartment complex. Typical costs or cons are noisy neighbor effect. So if one tenant starts to take up a huge number of resources, the other tenants are impacted, which typically would not be having if you had independent resources for each tenant. But as soon as you have a joint set of resources, noisy neighbor effect comes into the picture. Slower development, especially as you bring more logic into your application side, like if you are enabling multi-tenancy on your application, developers need to think through more scenarios. Testing becomes more rigorous because you need to handle how it interacts with, across the different tenants and so on and so forth, right? And obviously security, because you're bringing all your tenants closer to each other. Security is compromised to some extent. But then you also have a common security gateway to help all these tenants. So maybe that also has some pros and cons. But all of these need to be thought through, right? Before you actually decide to go through the multi-tenancy route. And even all these benefits and costs that we are talking about, they're all still in the context of what level of multi-tenancy you want. So remember, we spoke about who are the tenants, who are the instances. You do need to figure out where exactly do you want to enable multi-tenancy in your pipeline. So let's take a standard WSGI pipeline, right? You have clients which are browsers, mobile apps, tablets, etc. And then you have users who are going to be using these clients. And all of these are going to be interacting with a standard web server, could be Nginx, Apache, and so on and so forth. And then you have the WSGI server where you may be using Unicorn, WSGI, and again, various other tools out there, right? And finally comes the actual Flask application, which you spend most of your time developing. So that's the WSGI application. And then internally, your WSGI application could be interacting with databases, authentication mechanisms, Celery, async task, Redis caching, and so on and so forth, right? All of these are, again, internal resources that your WSGI application could be using to do different kind of business layer logic that you create in your stories and so on and so forth. So the main question that you need to figure out is, where do you want to enable multi-tenancy over here? And the most common answer, right, is basically that you want to have some amount of multi-tenancy for your client and server itself. So the typical place where most people draw the line is between the users and the web server. And that's mainly just because we're working on web applications. If you're working on a desktop application, that's also not there, right? You actually do need to deploy multiple instances of your application for each user. And then you don't even have any, or multi-tenancy just gets reduced, right? But typically when you're talking about web applications, multi-tenancy is at least maintained at a server and a client level, because you have multiple tenants, which is multiple users, accessing the same UI or the website that you have hosted on one of your servers. So that is the single instance which is going to be interacting with multiple clients. And the reason we kind of do this for web applications, and typically most people already understand the benefits of desktop versus web application, right? You don't need to deploy new patches or version releases to your clients. You don't need update mechanisms. Client-side changes like OS upgrades, etc., are not as relevant because you normally have a browser which interacts with it, but then you have browser compatibility and so on and so forth. And all of these pros and cons are very well known, which is what typically people decide when they're going to be doing desktop versus a web application. And the reason for web applications we keep the line at this point is because we're talking about having a separate server versus a separate client. Right? And that makes, and all of that stuff makes sense. But when we start talking more about multi-tenancy, we start figuring out where exactly do we want to draw the line, because there may be additional resources to gain or additional benefits that you could have if you're drawing it a little closer to your WSGI application. Right, so this is a typical scenario where you have multiple users interacting with completely different hardware servers, right, which have their own Nginx, Unicorn, Flask stack. So let's talk about the next step in multi-tenancy. If we want to enable the web server to have multi-tenancy, then we start talking about, well, subdomains is a very common thing, like a.abdeali.com, or you could even be talking about prefixes, like abdeali.com/a/b, etc. You could even have multiple ports, but typically people prefer using ATL 443 just because of the standardization of HTTP and HTTPS, and so on and so forth. And all of these techniques that we are talking about are all available already in most web servers, whether it's Nginx, Apache, or anything else that you're using. Right? So that's typically a very simple setup, right? You just want a single Nginx, which will then be routing to the different applications that you have. And these applications, again, could be in different hardwares, could be in different, or in the same hardware. That completely depends on how you want to deploy. So when we're talking about Nginx, at least for the example that I'm taking out over here, it's very simple. You just take locations which have different prefixes, and then you're just passing the information into the appropriate WSGI server's port that you have, right? So the location and the proxy pass are the common settings that most people use to enable the reverse proxy to move to the WSGI server side. So that's an easy setup, right? Nginx web servers, all of them already support multi-tenancy. It's quite easy to go there. Let's talk more about the WSGI server, where things get a little more difficult, right? Over here, we're talking about actually enabling multi-tenancy on the Unicorn side, and Unicorn doesn't support, or most WSGI servers' main responsibility is to handle threading, request caching, and so on and so forth. Not really the whole multi-tenancy aspect of things. So the typical answer to these kind of things is, hey, why don't we just create a middleware which will handle these things for us? So if we want to have a single instance of Unicorn, which is going to be delivering multiple Flask applications to your users, what we need to do is create a middleware which will be able to do the same routing that Nginx was able to do. And a quick note over here, I mean, Unicorn typically runs on a single port or a single domain. So now we're only talking about the prefix-based routing, right? Not subdomain, not port-based routing, which is all Nginx's responsibility. When you're talking about WSGI server, it's all about the actual prefix that you have in your URL, which then routes to the different Flask applications. And we were doing a lot of research and trying to actually create our own middleware at Corridor. But very quickly, we found that Werkzeug has a bunch of helper utility functions that pretty much make this really simple. So the function that we were using from Werkzeug was the middleware called the dispatcher middleware. So the dispatcher middleware, as you'll see, you first just create your standard Flask applications. You do various other initializations you want in your, typically, let's say the create app function or factory. And then you use the dispatch middleware, which is going to be taking in the WSGI application, which is the Werkzeug's application from Flask, and then also a configuration saying what are the other Flask applications or WSGI applications you want this dispatcher middleware to dispatch the request to. So here's where I have a simple example where I'm just looping over the different tenants that I have registered on my application. And using the prefix, I'm just routing it to, let's say, a different tenant application. So let's just take a look at the create tenant app, right? What this is basically another factory which can just give back a Flask application. So what you can do over here, remember what the main objective here is to have different Flask applications itself for each tenant. So this function creates the Flask application for each tenant, and then the dispatcher middleware essentially helps with dispatching it to the right tenant. Right? So whenever there is a request coming in for tenant one, it basically goes to the appropriate Flask application. Then the normal app context is created, the request context is created, and you can return back the result that you want for that tenant. Now, in this approach, it's the simplest approach because what you're doing over here is you're having a single GUnicorn which has its own thread of pool of threads and so on and so forth, but you actually have distinct Flask applications which are each doing their own job. And that's ideal, right? Because you have complete isolation between your Flask application. So whether we're talking about databases or whether we're talking about Celery, Redis, all of those kind of things, even the settings that you're going to be loading for your Flask application can just be completely independent. It can even have a different instance folder. It can have its own different templates, whatever it wants, right? So what we're doing over here is, again, we're creating separate applications and one application for each tenant. And then Werkzeug's middleware just helps us route it to the right way. So there's really very little risk of having any kind of interaction between your Flask applications itself. And this is great because now you can have a single GUnicorn which has a single set of processes which is going to handle everything for you, right? So you don't need to, let's say, allocate more RAM. You don't need to allocate more amount of CPU. It's just that, again, remember the noisy neighbor effect and so on and so forth. If one of the tenants starts calling a huge number of APIs, then all the requests will be allocated to that. GUnicorn will request all the processes to that specific tenant. So all of those kind of issues do come up, which are the standard issues for multi-tenancy. But at least we've simplified the amount of resources that we need for our multi-tenant application. Right, so that's basically the GUnicorn or the WSGI layer. Yeah, so this is just talking about the different URL paths. The next layer comes up is the WSGI application itself. So this is saying, hey, I've handled my Nginx, I've handled my GUnicorn. How do I say I have a single Flask application, but then I want to be able to handle multiple tenants for each application within my single Flask application itself? And there are some benefits to it. For example, why create multiple, if you're going to be handling hundreds of tenants, why create so many Flask apps, right? Because they all do take certain amount of resources and RAM in memory, but not as much as, let's say, creating multiple GUnicorns, but at least do take in a certain amount of it. So can we actually do it at application, like inside the application level itself? That was the next level that we were trying to think through. And that's where things start becoming more difficult. If you notice, the Nginx is a very easy route. The WSGI application also becomes, WSGI server also becomes relatively easy. But WSGI application is the next level, and it just becomes increasingly difficult to maintain, right? Which is one of the costs that we were talking about with multi-tenancy. And the thing over here with the WSGI application is it internally has many other resources, right? It could be databases, Redis, caching, etc. And now we need to handle multi-tenancy or at least the connections for each of them independently. And that could, depends on the kind of application you're making, but it could become more and more difficult. So what we did over there at Corridor was we actually leveraged the same concept that Flask uses for apps and requests and so on and so forth, which is the overall concept of local in Werkzeug. So Werkzeug has a module called Werkzeug.local, which helps us create local objects, local managers, local proxies, local stacks. Now, what's that all about? Right? Let's just talk a bit more about that. Now, this is basically just a set of utilities that Werkzeug is provided, which helps applications like Flask, like any WSGI application, which is typically meant to be multi-threaded, right? You want multiple threads for your application to handle kind of like the equivalent of global variables. It's kind of ironic that it's called local, but what it's talking about is a global variable which is local to every thread. Okay? The biggest issue when we talk about global variables in Python is as soon as you start doing threading with it, the same variable is used across the threads. So then you have locks and race conditions and all of these kind of things that come up. But with the local methods that Werkzeug provides, you can actually have a global variable which is only within a thread, like within the context of a single thread. And there are a bunch of helper classes that Werkzeug provides. The first one that we're going to talk about is local proxy. Right? Local proxy is kind of similar to just saying, I have a property, but at a module level. Right? There are actually a bunch of other ways of doing this, but Werkzeug provides local proxy. So what you'll see over here is, let's talk about the bottom layer. You have a current DB, right? Kind of similar to a current app, where we are creating a local proxy to a function that we have defined earlier, called the getDB session, right? And in the getDB session, what we are doing is we are using, in this example, I use SQL Alchemy, but this is it's a generic code that you could write for any ORM that you may be using, where we are creating an engine and a session for SQL Alchemy using a configuration for the current app, right, which is also another local proxy variable. And we're saving that into a dictionary, which is globally defined. Now, this dictionary is still a global variable, but at least every thread or every app will try to use only its instance of that application. Right? And this is just an example that we will be improving in the next slide. So what we're doing over here is we're essentially creating a proxy variable called current DB, which is saying whenever I'm going to be called, let's say whenever current DB is going to be called, it will go and access getDB session, or it will call getDB session and fetch the session which is specific to the current app. Right? So we are using a local variable to get another local variable. So it's essentially a proxy that we're creating over here. And this helps us because now what we can do is whenever we want to access the database, similar to how we say something like from flask import current app, we could also say from my application import current DB, and then use the current DB session to make our API calls or database calls, queries, filters, and so on and so forth. And it just becomes the DB for that particular thread that we're going to be using. Okay. Now, you could also use the local stack. And the local stack helps us to actually manage our tenant itself. So here we have an example where we're creating a local stack called tenant stack. A stack is just a normal stack data structure, which has push, pop, and top. And over there, what we're doing is we're taking the stack, and then we're creating a local proxy using that stack's top value. Right? And then we can also use the flask hooks, like the before request, tear down request, and so on, to say, using the header information, we want to get the tenant that we are currently processing, and then again, pop it after we're done with this particular request. So all of these can be done as part of the hooks that Flask provides and the local stack, which is provided by Werkzeug. And remember, this is just, again, a stack, which is, again, local for a thread. So this stack will be independent for every thread and will help us manage various kind of locking issues and so on and so forth that come up. So the benefit that we have over here is we can even track what is my current tenant, current DB, and even other things, right? Like if you go back for a minute, you have to handle all the different current objects that you have for your resources. It could be current cache, could be current file system, and so on and so forth. And that's where things get a little more complex. Because as soon as we start creating more and more current resources, it helps us to be able to toggle between the resources within a single Flask application. But then remember that you may be using a bunch of other extensions, right? All of them also need to start using the current DB or the current cache in the appropriate way. So all of those need to be handled if at all you're using any extensions which are trying to use them, right? If you're going to be using, let's say, Flask SQL Alchemy or SQL Alchemy Marshmallow, Flask Marshmallow, all of these kind of libraries, we just need to make sure that they're using the correct resource in the correct way. And that's where the complexity of development increases. Now, we've spoken about every layer, right? We've spoken about clients, user, web servers, WSGI server, and the WSGI application. But you could also handle each of your resources with multi-tenancy. Now, databases themselves are quite easy. You could actually have different databases themselves for your different tenants. But even that may not be an ideal situation, right? Because you may have a lot of common information across your databases that you don't want to replicate. You could even have common users that you may want to proliferate across all your tenants, common administrators and common settings. So what you could do over there is also handle multi-tenancy at the resource manager layer. Now, if I'm talking about databases, the standard approach that we use at Corridor is SQL Alchemy as the ORM. So using SQL Alchemy's method, we were even able to say, let's create multi-tenancy within a single database. Like let's say within a single SQLite file or a MySQL database or Oracle or MySQL, et cetera, right? How we were doing that was we were essentially creating the same concept that the user database typically does, but more at an application layer inside the SQL Alchemy stack. So let's say, for example, if ever someone is trying to do a query using SQL Alchemy, we override it and we use our current tenant to be able to only query the information from the current tenant. Every time someone's trying to create a constraint, let's say it's a primary key constraint, or if it's a unique constraint, we automatically add the tenant variable as a composite primary key or a composite unique constraint. And you can even override the session to handle various things specific to this tenant so that you're expunging or doing refreshes, etc., for this current tenant. So here's like a quick example, right? If you're going to be talking about unique constraints, you can take the SQL Alchemy event, listen for unique constraints, and whenever it's going to be attaching a unique constraint to a parent, like a table or a model, etc., we essentially say, take the unique constraint and add an extra column to that unique constraint, which is the tenant column. Because anytime you want to create a unique constraint, let's say by ID or name or any other variable that you're going to be doing it, and it could be, again, it could be an existing composite unique constraint or a single column constraint, we can just automatically add the tenant column into the mix so that the unique constraint is always about the name, alias, ID, whatever you're using along with the tenant, right? Because essentially you want it to be unique for every tenant that you're going to be using. But again, this just adds a layer of complexity because this needs to be handled for many other things. For example, primary keys, for example, queries, for example, the identity function that SQL Alchemy internally uses, and so on and so forth, or even the session scopes and so on. So the main point over here is that at every layer that you're going to be adding multi-tenancy, you have a different set of benefits and costs. When we're talking about it just at an Nginx layer or just at a server layer, that's the simplest level that any web application typically tries to handle multi-tenancy. But then you may also need to do it for WSGI server, which is still easier, WSGI application, which adds some complexity of the kind of plugins or modules you're using, and then going all the way to even database, to the Redis, to Celery for tasks, to your LDAP systems, and so on and so forth. But even over there, now you need to have separate groups for each tenant. All of these kind of things need to be managed one by one as you're trying to add multi-tenancy. But the great thing about this exercise was you can essentially do it incrementally, right? It doesn't have to be a one-quarter effort where you're going to try adding multi-tenancy to your entire application. At every layer that you add multi-tenancy, you can actually get like a benefit of nearly 20 to 30% of the resources which you're saving just by adding multi-tenancy. So that's amazing, right? And that's the kind of step-by-step approach that we typically take, or I typically prefer as soon as we're going to be adding a new architecture component into our stack. So yeah, that's about it. Thanks a lot for listening through. If you have any questions, feel free to reach out to me on either GitHub or Gmail or Discord and so on. And there are a bunch of references that you can take a look at to take a look at how Nginx, Werkzeug, and SQL Alchemy work with some of the concepts that we are talking about right now.